First things first, a little housekeeping. So Mr. Kulik made a mistake, kind of a big one. So your grade calculation, I transposed two of the weights in the categories. So tests are supposed to be 50%, and then the exam is 15. I transposed those at the start of the year. I switched them this morning. So if you go and you look and you see like, why did something change on my grade? Like, that's what happened. Just giving everybody a heads up that that happened this morning. That was a mistake on my part. I apologize for that in advance. Yes.
So if we're not taking an exam, where does that 15% go?
I just becomes evenly distributed.
Oh, evenly distributed.
Yeah. Yeah, like everything else just picks up an extra 5%.
Okay.
Wait, can you explain what you just said, like, again?
So the weights attached to the test category and final exam category were switched. So it's supposed to be 50% on test and 15 on the final. I had it the other way around, and I switched it this morning.
Okay.
I realized it over this weekend when I was looking at what the conferences were going on. I was looking at scores. I'm like, this doesn't make any sense. Like, why is this grade? And I figured it out. I'm like, oh, darn it. Did I do it just in this one class? Nope. I did it on all of them. So it was like, ugh. Anyway, so I did that this morning. So if you notice, some of us it like little changed. Some of us, depending on how your test scores were, might have made a bigger change. In speaking of test scores, if you guys have not yet completed your points back assignments, ideally let's try to get that wrapped up this week. So, Ava, Kylie, Sarah, Adriana, somebody else I'm not thinking of, maybe, I don't remember, there's first hour people still. Try to get together with your person, figure out a time to come in during CT this week. Let's try to knock that out. Additionally, I spoke with Miss Elwood at the end of last week, and it sounds like she's gonna do all of her biology tests on Wednesday. So we're gonna do our optimization mini test there on Friday. Sounded like second hour that schedule change on her end had not been well advertised yet, so I apologize if you're just now finding out about your biology test moving from me. We'll talk some more do some optimization review on Wednesday. We'll take part of the class and do a little bit of that on Wednesday. The format for that optimization mini test will be the same as the related rates. We'll have 5 multiple choice, 2 per response, you pick two of the 3 questions to do, that kind of thing. So, okay? All right. So today, at this point, we've done a lot on volume, right? We're gonna pause here on volume for a little bit longer. And I think we have like 5 assignments or something stacked up here that have to do with like finding the volumes of things. There was 6.2, there was the packet, there's 6.3, there was 6.3 mixed with 6.2. There's a delta math. Do you guys have questions from any of that stuff? Like now is a good time to fire off a couple of volume related questions, and then we're gonna do a little bit more practice today here in class. So if you guys have questions on something, Caroline?
Well, I was just gonna ask if you know about when our next test, not the optimization test, but the other one, about when that will be?
Well, it would probably be looking to fall during Irish week, but I don't know if we have a regular length class at any point during that week. So it might be one of those where we do new stuff and then take our test the following week. I've yet to see the schedule, like the class schedule for Irish Week, to know for sure. But I suspect that'll kind of be the case between mass and concert and Trivial Pursuit and probably something else that I don't know that there'll be a regular length period in there to guarantee.
One day, but like the B day and A day don't match. So it's like one day we have math on Monday, and then the next day we have like regular classes, but then after that it's all like Irish Week schedule, so it's shortened.
Yeah, so it might be one of those where just like we start the new stuff and just worry about the test the following week, where like everything is kind of opened up there a little bit. It's less of a hassle, if that's okay with everybody else. I think we still have another week before everybody leaves for spring break, so that feels like a good time to make sure we get the test done before. Sound okay to you guys? Caroline, you happy with that? Fair enough. We'll talk more, like, once we figure out, I think I should finish the test 6 content this week. And we'll figure out what we want to do testing wise, but I feel like that's probably in everybody's best interest, is to just like try to do this during the chaos that is Irish Week. Okay, go. Homework questions from stuff. Adriana.
I have one from 6.3.
Sure, what number from 6.3?
Number 19.
Number 19. Let's see here. That's the stuff there. All right, so these questions say to use cylindrical shells to calculate the volume, rotating about the specified axis. So I'm going to start by just kind of sketching myself a picture of what my graph would look like, or the area anyway. So we have y equals x cubed, and then about 1, or y equals 1. So I'm going to say like so this is my area, the bounded region between y equals x cubed, y equals 0, and x equals 1, right? And then I have like there's my axis of rotation. Adrian, does that feel pretty good as far as a picture goes? Make that a little bigger for us now. Okay. So first thing I'm going to do is I'm going to draw in my radius and my height for my cylinders. So the radius always originates at our axis of rotation, and then we draw to that shaded region. So that's like my radius. And then my height is always drawn through the shaded region. Questions on the picture setup here? And I guess I should have, put that on there. Okay, so the first question I'm going to ask myself here is dx or dy? what am I integrating with respect to? dy. How'd you figure that out, Anthony?
Parallel to y-axis.
Okay, so it's the radius is parallel to the y-axis in a shell problem. It's a dy problem. Okay, if it was parallel to the x-axis, it'd be a dx problem. Or the way I think about it is the y is a vertical, or the radius is a vertical distance. That's the part that's changing. So that should be my variable of change, should be the y coordinate, because it's a vertical distance. Any way you want to think about it is fine though. So it's dy. So far so good? Okay. So that's step one. Now this point where the radius is intersecting the curve, or the shaded region there, is the point xy, right? It's arbitrary. So the radius here is going to be related to which coordinate? The x coordinate or the y coordinate? The y coordinate. That's correct. So I know this distance here is y, and this distance from here is 1. So what is the radius in relation to y? 1 minus y. That's like my radius. Is everybody okay there? Now I'm going to look at the h. Since the h is a horizontal distance, which coordinate is related to? X. Now, I know that distance is x. That distance is 1. So h is 1 minus x. Right? Shouldn't be more than 1 because h is shorter than 1 unit, right? Does that make sense, Ava?
Mm-hmm.
Okay. Now, what variable am I integrating with respect to? Y. So I have to rewrite x in terms of y. So I know that y is equal to the x cubed. So x is just the cube root of y. And that should be my setup. Now, for the record, if I'm doing this problem, I would probably do this as a washer problem rather than a shell. Probably easier to do, more obvious what to do as a washer problem. You do not need a shell here, just for the record, but the directions ask us to do it as a shell. Ava, you had a hand.
Yeah, I'm just confused on like where you got that like that distance h is 1. Like, does it say it somewhere?
So our graph is y equals x cubed, and it's bounded by y equals 0 and x equals 1. So I know this point is like 1, 1, right? This point is 0, 0. So I know the horizontal distance is 1, and the vertical distance here is 1, right? So if h, I know, is from 0 to 1, that's 1. 0 to the point is x. Stop. So the leftover should be 1 minus x.
Oh, okay.
Is that?
Yeah.
So it's the same kind of reasoning that I did for r, right?
What numbers would be the bounds for the integral?
Great question. We're integrating with respect to y, correct? So what's the shortest my radius could ever be? 0. And the longest could ever be is 1. So we should integrate from 0 to 1. Which is also from y to 1. Because we're integrating with respect to y. And that's usually how that'll match up. Every once in a while, if the radius is like 1 minus something, or you might have to be a little bit careful there if there's negative numbers involved. It's a little yucky, but for the most part, it's probably just, you know, the boundary of the coordinate that you're integrating with respect to. You feel better on that, Adriana?
Yeah, thank you.
So again, like, once I drew a good picture, and like once I've labeled my parts, and like once I describe those parts in terms of the x or y coordinate, it's not bad to build my equation, right? To build the volume function. Until I've drawn that picture and labeled the pieces, I can't do it without doing that. Like I literally, I'd have to sit there try to visualize it, and it's rough. If I can visualize it, if I have a picture to work from, it's not so bad. That really needs to be the first step. Okay. Other questions from homeworks? Happy to do more if there's others. Ava.
Could you do lower 6 and the volume by cross sections?
Yes. That was the example one. That is some answers. Is this the
Yeah, I guess.
Is this the set right here? That's the first question?
Mm-hmm.
Okay, which number then?
6.
6. Happy to do that. 6. Okay, the base of the solid in the first quadrant is bounded by the graph of yada, yada, yada. So here's 0, 2, and it's just a straight line going down to 3, 0, it looks like. You okay with how I figured that out? Just plug 0 in for. Okay. Oh, and it tells me from 0 to 3. Okay. Each cross section perpendicular to the y-axis. So there's my cross section. Is a rectangle whose height is 5 times its width. So let's say that this is width. So my area function is going to be length times width, right? Or I should say, let's do, oh yeah, okay. Height times width is what they're calling this. And we're told that h is 5 times the width. So we have that. So far, so good?
Yeah.
Okay. So this W is a
X.
yeah, so W is equal to X. But we're slicing up and down, right? Because we're perpendicular. So we need that in terms of Y's. Oh boy. Let me just do it down here, I guess. Is it 2 minus 2/3? So I subtract the 2 over, and then multiply by 3 over 2, negative 3 over 2. And so that's going to be my W. And then it's just integration time. Is it okay if I stop here?
Yeah.
Okay. You feel good with the setup as to what we did?
Yes.
You knew how to determine it was a dy versus dx. It's the first critical thing that has to happen, right? After you figure out like, what type of method am I doing? You know, am I doing a shell or a washer or a disc or some other cross section? Those are your 4 choices. Then it's, am I integrating with respect to x or y? And then I start figuring out what are the equation for my pieces in terms of the variable of integration. And I plug them in, figure out my bounds, and then integrate. Other questions from homeworks? Okay. For today, we're just going to pause on volume. I have some practice. We're going to spend time in class working on these practices. You should find a partner to work with, someone that you can talk to talk through, like, what are we doing? Why are we doing this? To talk about, should I do a shell or a disc or a washer? Are we integrating with respect to x or y? Did I draw the picture right? Is this the part that I call the height or the width or the radius or whatever? Talk through this stuff with a partner. I want to point out to you that basically the problem, there's like 3 separate problems, and then I just change, it's the same area in each of these 3 sections. The only thing that's changing is like, what are we rotating it about? Okay. Now I do have 3 edits to make on this because Lord knows I didn't proofread this close enough and I made 3 mistakes. So on numbers 1 through 6, there needs to be an additional boundary for the region form. So you need the curve, y equals log base 2 of x, y equals 0, x equals 1, and x equals 4. So on 1 through 6, you also need that extra x equals 1 in there to give you an area. Otherwise, the area is like infinite. Well, infinitely sized because the asymptote, we don't want to muck with that. For 7 through 11, let's make all those instead of plus 12s, let's make them all minus 12. Otherwise, we have irrational bounds and like that just stinks to deal with. And then on 12 and 13, you can eliminate where it says end the line x equals 4. You don't need that for 12 and 13. So those are my 3 edits. For this sheet, all I want you to worry about is the setup. Okay? You don't care about what the actual volume is. You can type it into your calculator and like, oh, did you get the same thing I got or whatever? Like, that's totally fine. Like, but some of these are things you can't even do. You won't even do by hand. I wasn't careful enough to make sure that everything was going to come out as stuff that you can do easily by hand. I didn't worry about it. The point is just kind of like setting things up. So in terms of like approaching the problem, get yourself a picture of the area. I mean, you could probably use the same area picture over and over and over for like 1 through 6 or 7 through 11 or whatever. But you need that region. Figure out disc, washer, or shell. That's your first step. After you've decided which one of those 3 you want to do or that you need to do, dy or dx, which variable you're integrating with respect to. Then you want to rewrite each of the dimensions, the radius or the height or both, in terms of the variable of integration, plug them into your formula and you should be done. Okay? There'll be problems on here that you could do as, like shell or disc, or shell or washer, or most appropriately just shell. So just kind of be on the lookout here. The goal here is mostly to get comfortable with being able to set these up in different ways and being able to choose the appropriate method or whatever. Okay? I have answers, so if you want to come and check things along the way as you're working, feel free. Or if you get stuck and you just want to talk stuff through, feel free. But that's the plan for the final, 40 minutes or so, or 60 minutes or so, 55 minutes, 54 minutes or so of class, is to just work on this and try to get a little bit more comfortable at doing these volume problems than we were when we walked into the classroom. Fair enough? Does everybody feel like we need a little bit more volume practice? Maybe other than Anthony, who felt like he's got this. Yeah. Well, he's the only one that was like immediately answered, like, what variable am I integrating with respect to, and like was no hesitation. Gave a good explanation as to why. So I felt like, okay, he's got it. All right. Go ahead.